Hello, everyone. Good morning, good afternoon, and good evening to all. Dear authors and invited guests, welcome to the technical session 10A. I am Anisha Mishra, the moderator of this session on behalf of Global Knowledge Research Foundation. It is my great pleasure to welcome you all to the 6th World Conference on Smart Trends in Systems, Security, and Sustainability through Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. There is a special note for all the presenters. You all will be given 12 minutes for your presentation and 3 minutes for question and answers. And on 10 minutes, I will raise a gentle reminder. There's another request to all the participants that you all please stay connected with us till the closing of the session. If you have any update or query, you can write it to me in the chat box. So just before we get started, I would like to introduce the session of the chair of the session, Professor Parikshit N. Mahale. Dr. Parikshit Narendra Mahale is a professor and head of Vishwakarma Institute of Information Technology, Pune, India. He completed his PhD in computer science and engineering specialization in wireless communication from Aalborg University, Aalborg, Denmark. He has more than 19 years of teaching and research experience. He is reviewer for Springer Journal of Wireless Personal Communications. Also, reviewer for Journal of Engineering, Science and Technology, School of Engineering, Taylor's University, and reviewer for Elsevier Journal of Applied Computing and Informatics. He is the member of editorial board for IEEE section on Information Forensics and Security. Welcome to the session, sir.
Thank you, ma'am. Thank you. Thank you.
Okay, so now we'll start with the papers. So our first presenter is Evgeny, and the paper title is Methodology for Implementation of Intelligent Risk Management in the Business Process of Organizations. Dear presenter, you may please start your presentation.
Hello, good afternoon. Do you see our presentation?
Yes.
Yes, we can see it. Please go ahead.
Thank you very much. Thank you very much.
Dear colleagues, together with the co-authors, we will present to your attention a report of methodology for integration of intelligent risk management in the business process of organization. It is related to part of the task for the implementation of national project on integration of risk in the business process of organization, financed by Bulgarian Science Fund. The authors of this research are Evgeny Volchev from the University of Plovdiv, with scientific interest in the field of AI, and Petya Biolcheva from the University of National and World Economy, who has experience in risk management. In order to avoid connection failures, we prepared a voiced presentation. For questions, we will remain available. First of all, it is necessary to see how risk management needs to be managed in an intelligent or AI-based way. The reasons are many, but some of the most important are the high dynamic of environment accompanied by many economic and geopolitical shocks, threats in individual business process, and the risk they pose as a result of the chain effect of all necessary processes in the organization, need of competitive advantages, satisfy stockholders, and while supporting a high reputation.
Some of the main advantages of intelligent risk management are identification of internal risk in individual business processes. AI reduces manually collected data, provides clearer risk identification, shows real-time results, processes internal risk information and relates it to relevant processes in real time. Identification of external risks. AI performs scanning and filtering of third-party information and links it to the business processes in the organization. Risk analysis and assessment. It illustrates the probability and impact of a single risk, taking into account all current data and linking them to historical models. The relationships between certain risks are assessed through machine learning, identifying interactions that are not easily noticeable. Impact on risk. It allows faster and more adaptive responses to the identified risks. Monitoring and control. AI provides greater resilience by avoiding accidents, faster response times by sending higher level warnings, and triggering the whole risk management process from scratch. To establish a common path that business organizations must take to ensure that intelligent risk management works, we have developed a roadmap. At first glance, our roadmap has a traditional look. We implement a procedure for integrating risk into the organization's business processes in 4 main stages. First, analysis. Second, preparation for implementation. Third, implementation. And fourth, monitoring. On the slide, you can see details of each of the stages. I will focus on the most important part of it, which includes our scientific contribution. This is the IRM BPM methodology, Intelligent Risk Management in the Business Processes of Organizations. The risk management process follows the standard ISO 31000 from 2018 named Risk Management. In each sequence of applied stages is added a conceptual vision for the application of individual tools of artificial intelligence. The IRM BPM methodology starts with risk identification. Within its framework, input information is needed for all business processes performed in the organization, as well as details for the activities taking place in them. In addition, an initial expert analysis of the activities is required, which defines all dependent factors and parameters that affect them. On this basis, the relationships between the individual parameters and their relevant activities and processes are expertly determined. Other required information that is needed for further analysis of artificial intelligence is related to the definition of historically known risks for the internal and external environment of the organization. The availability of the information provided so far is the basis for triggering smart risk identification. Its implementation is based on many principles, the main of which are AI analysis of information for defined risks, AI analysis of information over activities and processes, application of semantic analysis over activities and processes, analysis of available data and knowledge from machine learning and neural networks, application of AI and neural networks to generate conclusions and solutions for potential risks after applying the technological and conceptual capabilities of semantics, neural networks, and others. The most significant contribution of intelligent risk management is that based on known risks and relationships, AI conducts its own analysis, taking into account changes in all internal and external factors. As a result, it draws conclusions, generating a current risk profile of potential risks to each business processes in the organization. The second stage, which includes the IRM-BPM methodology, is follow-up with risk analysis. This stage is performed autonomously without the need for an expert's participation. Base for conduction of the analysis are the already obtained data from the smart identification and subsequent analysis by the AI tools for the main dependencies and characteristics of the risk. Some of the actions carried out by the AI tools are analysis of the frequency of risk with machine learning based on historical data, analysis of the financial consequences through machine learning and meta-information, machine learning continuity risk analysis for the business processes, direct and indirect linking with other processes and activities, impact of risk on the entire business organization, potential effects of risk over stakeholders, semantic analysis of other factors influencing the risk. Within the qualitative assessment, each of the characterized risks is compared with the level of the risk appetite of the organization through AI analysis. It optimizes the processes to the extent that it facilitates expert assessment by applying an analysis based on all available information and predicting the company's risk appetite. In this way, its level is established and classified as low, medium, or high. By autonomous generation of probability matrix based on neural networks and semantics, it is possible to derive the location of each risk. For higher accuracy in intelligent risk assessment, quantitative assessment is also performed. It is conducted on the basis of Monte Carlo simulation, whose functions are improved by AI algorithms and tracking the overall processes and combinatorics of information flows. The results of the intelligent risk analysis stage are summarized in the generation of an intelligent assessment for each individual risk. The next stage of risk management is the treatment of risk and its monitoring. Due to the dual nature of risk, here intelligent analysis continues in two directions. On one hand, it must respond to the possibilities proposed by the risk, and on other, to the threats it poses. As their possible answers differ, they are grouped separately. The most important decision that the tools of AI, in this case machine learning analysis, should make at this stage is the choice of an appropriate response to each individual risk and its impact on all related activities and processes. In order to obtain a high level of assurance and follow-up training for the machine learning algorithms, additional analysis is conducted to provide information on the level of residual risk after the treatment. Machine learning plays an important role in implementing maximum optimization and proactively ignoring or minimizing the risk factor. An important stage is the training of machine learning based on the implemented utility models and the input of useful information coming from various sources. If it does not meet the risk profile of the machine learning algorithm, the organization conducts a new analysis and proposes measures for additional impact. Then the process is repeated until the maximum training of the machine learning algorithms is reached to bring a high level of truth of the analysis process. The monitoring provides connection and presentation of the synthesized and normalized information to the experts and the personnel with the help of the modern technologies. If subsequently the artificial intelligence analysis registers the presence of a new risk or change in the status of the so far managed. The process starts again with intelligent risk identification.
By integrating the IRM BPM methodology, business organizations will increase their competitiveness. The main contributing points of IRM BPM in business process are related to increasing autonomy, the ability to improve over time, updating accurate results based on comprehensive data, real-time risk management without the need for additional human resources, minimized cost, and other.
Dear colleagues, thank you for your attention. For additional questions, feel free to reach us via our emails.
Hello. Yeah, can you hear me?
Yes.
Yeah, it was a good presentation. I have few questions. Which specifically which part of AI you have used for this IRM? Whether you have used machine learning or you have used deep learning or something else?
Yes, machine learning and deep learning are supposed to be used as basic methods, and this is just conceptual learning in the moment, and we are working over the entire conception. But in general, this is machine learning, which will takes into account a present or a past events in order to collect data and to sophisticate itself and to present a future decisions or proposition for decisions, how the risks to be managed by the organizations.
Okay, so your data set which you have, is it labeled data set or annotated or non-annotated?
Please, I couldn't understand. Please excuse me.
Your data set which you have or which you are planning to use, that data set is labeled or non-labeled? I hope my question is clear. Yes, can you hear me?
Yes, I can hear you, but I'm afraid that I cannot answer.
Okay, you cannot answer. Fine. So existing literature, what it shows that accuracy is 70%, 80%. Have you studied some existing literature on that?
Beg your pardon, please. Could you repeat?
Have you explored some existing papers where AI is applied to IRM, where AI is used for intelligent risk management, and what is the accuracy? Is that question clear?
This is just a conception. It is not yet conducted a practical study with the artificial intelligence.
I know that. My question is, in the literature, what is the accuracy you have found in the literature?
I cannot answer.
Okay, fine. Good work. All the best. Thank you.
Thank you very much.
Okay, thank you for your great presentation. Now we'll move further to our next paper. And I would like to invite Yahya Zefri to present his paper on the title, A Channel-Based Attention Deep Semantic Segmentation Model for the Extraction of Multi-Type Solar Photovoltaic Arrays from Large-Scale Orthorectified UAV RGB Imagery. Dear presenter, you may please start your presentation.
Hi, do you hear me? Do you hear me correctly?
Yeah, we can hear you. Please.
Yes, please go ahead.
All right. Do you see the presentation?
Yes.
All right. So Hi, we are honored to take part of this edition of the World Conference on Smart Trends in Systems Security and Sustainability. In this presentation, we're going to present our work entitled A Channel-Based Attention Deep Semantic Segmentation Model for the Extraction of Multi-Type Solar PV Arrays from Large-Scale Ortho-Rectified UAV RGB imagery. During their operating lifetime, solar photovoltaic modules endure various stress factors and environmental conditions. These include contrasted temperature profiles, humidity, winds, precipitations, as well as handling and installation. As a result, modules get affected by multiple defects that develop over time and penalize the electricity production. To detect these defects, remotely sensed imagery by means of UAVs is increasingly used thanks to its reliability and cost effectiveness. Besides thermal imagery, RGB imagery is frequently used to characterize PV surfaces. RGB sensors provide very high resolution images. These images can be used to detect reliably various defect types such as discolorations, delaminations, cracks, and snail trails. The RGB information makes it possible also to interpret thermal patterns more accurately, spot false hotspots, and detect some defects that are not detectable through other imagery types. PV arrays are installed in highly varied layouts, which makes defects detection directly from the images highly challenging. Towards this issue, multiple research works tend to implement a prior PV extraction phase, then perform detection on the extracted areas. In this way, detection algorithms operate directly and more efficiently on module surfaces. False detections that may result from the background are eliminated, and more computational time is gained. PV array extraction is also a key tool in mapping PV sites. Additionally, it can be used as a tool in estimating the generation capacity of these sites through area computation of the extracted surfaces. This work is part of the Smart Drone for PV project conducted in collaboration between the School of Geomatics and Surveying Engineering from the Hassan II Institute of Agronomy and Veterinary Medicine in Rabat, Morocco, and the Mohammedia School of Engineers from the Mohammed V University in Rabat, Morocco. Smart Drone for PV is supported by the Moroccan Research Institute for Solar Energy and New Energies and the enterprise ETAFAT. It aims at developing market-oriented and deployment-ready PV inspection solutions for large-scale applications using advanced UAV photogrammetry, deep learning solutions for defect detection, and big data analytics to handle the huge data sets that are generated by large-scale plants. The general methodology of our work comprises two blocks. The first is data preparation. RGB images were collected from 4 PV sites. Acquisition was performed using a UAV type Phantom 4 Pro. The flight height was set to 35 meters and a percentage of 60% was set for the overlaps between images. Images were afterwards processed following a structure from motion multi-view serial pipeline, and PV surfaces were digitized, then rasterized to generate labeling masks where pixels of values 0, 1, 2, and 3 refer respectively to the background, monocrystalline, polycrystalline, and thin film surfaces. The labeling masks and the orthomosaics were tiled following a squared grid of 256 pixels, and a unique ID was assigned to each side plus mask. Finally, the tiles and the PV modules were filtered, randomly shuffled, then split under a 70, 20 to 10% training to validation to test split. The second methodology block is model development. Herein, the model proposed in this work was developed starting from the LinkNet core architecture and comprises a contraction and expansion paths. The former was customized through implementing 3 squeeze and excitation ResNet-based channel attention backbones, respectively with 18, 34, and 50 layers. Training of each model was performed using the Adam optimizer, a batch size of 32 tiles for 50 epochs with a learning rate decay of 0.93. The models were implemented using TensorFlow and the Keras library. The squeeze and excitation channel attention blocks model the intrinsic channel dependencies of a tensor, allowing an ulterior recalibration where more important weights are given to the channels to which increased attention should be paid and vice versa. ECE blocks can be integrated seamlessly in existing CNN architectures with negligible added computations. In total, 1,566 RGB images were obtained from 4 sites, featuring modules in highly varied spatial layouts. The SFM MVS processing workflow produced 4 georeferenced orthomosaics with an average ground sampling distance around 1 centimeter per pixel. The digitization and the vectorization process produced in turn 4 corresponding binary labeling tiles. And initially, 7,313 tiles were generated with their corresponding labeling masks. Figure 8 tracks the progression of the mean intersection over union and the F1 score of the 3 models computed on the training and validation sets. Starting from epoch 35 approximately, a general stability and convergence are observed for all the models. SeriesNet 18 stays at the top and has the smallest generalization gaps, which is the difference between the training and validation curves. No underfitting or overfitting patterns were observed for any model, which means that the training of the 3 models has been performed optimally. On the held out test set, the highest performance was a new achieved by SeriesNet 18, which scores a mean intersection over union and F1 score of 86.67% and 92.2% respectively. Therefore, the model was selected as the final candidate for the addressed task. Herein we have sample thresholded predictions of SeriesNet 18 applied on test tiles on figure 9. The figure illustrates how the multi-type model predictions adhere well to the original images with very negligible differences compared to the labeling masks. For a practical deployment, an input orthomosaic has to be tiled, then passed to the model, which will generate the prediction tiles as illustrated. The latter have to be thresholded, then mosaic to obtain at the end the whole prediction map covering the entire PV site. For future work, we suggest collecting more data from additional sites to enhance the model robustness and performance. 2, exploring additional deep semantic segmentation modules, namely spatial attention-based and transformer-based models. And finally, addressing an instance segmentation task where the modules are extracted individually instead of the complete array. We'll be delighted to share with you in upcoming opportunities the latest results of our research activities. Thank you.
Can you hear me?
Yes.
Okay. So you have used deep learning for your implementation. So can you elaborate on which platform you have used?
What do you mean by platform?
The computing platform. What are the implementation platform?
So the computing platform will be a workstation or whatever laptop. So images will be acquired on field, processed following a photogrammetric acquisition post-processing workflow, then passed to the model, which is implemented within a computer that will process the generated orthomosaic and generate the prediction of the entire inspected PV site to detect every type of PV solar panel that is existing.
So have you used any high performance computing platform like GPU or CUDA?
Yes, we have used CUDA and
CUDA.
QD and N because we have used an NVIDIA GPU card, and to
Okay.
benefit from the accelerated computation that is provided by this card, CUDA and QD and N have to be installed priorly. Otherwise, the laptop will just use the CPU to perform the computations, and that will be not enough.
Okay, so this NVIDIA card consists of how many cores?
I don't remember exactly how many cores it has, but it is an NVIDIA RTX 2016.
Okay, okay. And then what is the level of accuracy you have achieved here?
The level of accuracy for the predictions.
Right, for the prediction.
So it was, we had an F1 score of 92.2%.
So how did you validate it?
We have validated it using a test set, because the model was first trained on the training set, validates on the validation set, then furtherly test on another test set that we have prepared.
That's good. Very good. Thank you. Good work.
Thank you for your great presentation.
Welcome. Thank you.
Okay, so now we'll move further to our next paper. And I would like to invite Ella M. O'Day to present her paper on the implementation of smart home security network using Internet of Things system. Dear presenter, you may please start your presentation.
Hello. Good afternoon.
Yes.
My name is Ella Awada. I'm a master's student in cyber physical system in At University from Jerusalem, Palestine. On behalf of my supervisor and my co-author, Dr. Isam Ishaq, I'm pleased and excited to present to you our study about the implementation of a smart home security network using Internet of Things system. Sorry. In my presentation, I will talk about the reasons that drove me to implement such system, the main aim of my project and its objectives as well, the methodology I followed in order to implement this system. I will talk about how I managed to remain the system security, the importance of the project, and my future work. Well, the foremost concern of all families is to maintain their families safe and secure. But however, studies shows that there was an increase in the number of home fire victims around the world. Other studies shows that there is increasing in the number of robberies by unauthorized entry. Studies that are related to babies' safety shows that babies need to be at a room temperature of 24 degrees. Solving all of these problems will help in achieving the third goal of sustainable development goals, which is to ensure healthy lives and to promote well-being for all at all ages. Well, I wish we can solve all of these problems, but fortunately, we can contribute in solving some of these problems. Our project main aim was to employ the Internet of Things principle in constructing a home security system. The objectives of our system was to construct a smart temperature monitoring circuit and use the data extracted to control the temperature inside the house, to construct a smoke detection circuit and utilize the data collected by the sensor to launch the siren when necessary. And the last one is to construct a touch detection circuit for door security. Moving to the methodology I followed, this project focused on how smart security system was implemented. As shown in the block diagram, the system consists of 3 sensors and 3 actuators, a temperature sensor, and smoke and gas sensor, touch sensor, the ESP32 microcontroller, a fan, and 2 buzzers. The ESP32 microcontroller is connected to the ThinkSpeak website, where I pre-installed 3 channels. Each channel is dedicated to receive data from each sensor, 1 channel for temperature sensor and 1 channel for touch detection sensor, and the last channel is for gas and smoke detection. This is a picture of an example of how we can distribute the sensor and actuator inside the home. For example, we can put the temperature sensor in the bedroom and the fan also in the bedroom. So when the temperature sensor detects a temperature that is let's say above the defined value, the fan will work. And the ASP, the microcontroller, will send data continuously to the temperature channel that is pre-installed in the ThinkSpeak website. Hardware description. In order to implement the system, I use 3 essential components. First, the ESP32 microcontroller, which is a rich microcontroller, has a built-in Wi-Fi, Bluetooth, and it's specially for IoT application. The second essential component is the MEQ gas detection sensor, which can detect the presence of different gases in the air, such as the carbon dioxide, the methane gas, and the argon gas. The last essential components of my system is the LM35 sensor, which can detect the temperature from the surrounding. The circuit, the system was subdivided into subsystems. The first subsystem is the temperature detection circuit. In this circuit, I connected a temperature sensor with the ESP32. I also connected a servo motor, or as you can see from the photo here, I connected a fan. In the second subsystem, I used, which is the smoke and gas detection circuit, I used the MEQ, a gas detection circuit, a gas detection sensor, and a buzzer, as you can see from the photo here. And the last circuit, the touch detection circuit, I didn't use a touch sensor because the ESP32 has a built-in touch sensor. So I only connected a wire to the pin number 2 of the ESP32. And this wire can detect human skin if somebody touched the wire. This is the system altogether. I built a wooden house as an example. So I distributed the sensors inside this house and put the actuator in the house. For example, I put the smoke and gas detection sensor in the kitchen, the temperature sensor in the bedroom, and I connected a wire from the ESP32 to the door. It's supposed to be a door. Software description. This system is supposed to detect temperature, smoke, and door security. So after running the ESP32, the sensors will start detecting data from the surrounding. For example, if the temperature sensor will detect temperature data from the surrounding. If the temperature detected by the sensor is above the defined value in the code, which is 25 degrees, the ESP32 will make the fan works. In either cases, if the temperature is below or above the defined value, this data will continuously be sent to the ThinkSpeak cloud, and especially the temperature channel that is dedicated for receiving the temperature data from the sensor. And the same for the smoke and gas detection and for the door security detection. Okay. For more clarification of the software description, I've created a sequence diagram for each circuit, but in this presentation, I've added only an example of the sequence diagram of the temperature detection circuit. So, as I mentioned earlier, if the temperature sensor will detect temperature from the surrounding, and it will send the data detected to the ESP32. The ESP32 microcontroller will compare the data received by the sensor with the defined value. If the temperature detected is above the defined value, the ESP32 will make the fan on, and in either cases, the ESP32 microcontroller will send the data to the ThinkSpeak cloud. As I mentioned earlier, I've created a channel in the ThinkSpeak cloud website. First of all, I've created an account in the ThinkSpeak. I've created a channel for each sensor that is dedicated only for receiving data from this sensor. So I've created a channel for smoke sensor and a channel for the temperature sensor and a channel for the touch sensor. Then I've opened this channel and took the API key and pasted on the code. So by this, I can make sure that this channel will only receive data from this sensor. Results. I've added some videos that show how each sensor receives data and how it can be visible on the channel and actuator. This is the temperature detection circuit. I used a hair dryer to increase the temperature around the temperature sensor. As you can see from the first of the video, this is the data received by the ThinkSpeak channel. As for the touch circuit, as I mentioned earlier, I've only connected a wire with the pin number 2 of the ESP32 microcontroller. When I touch the wire, the buzzer will go on. And this is for the smoke detection circuit. I've used a cigarette to produce a smoke near the smoke detection sensor. And this is how the smoke, and this is how the data is varied in the channel. The main challenges of the IoT system is security. The IoT device is not designed to be secure. However, I've used some security setting in order to maintain my system secure. The first one is, as I mentioned earlier, the using of ThinkSpeak API keys. So I copy the API keys from the channel and paste it in the code. By this, I can make sure that only me, the one who has the API key, can observe the data that is transmitted to this channel. Another security setting I use is the Wireshark Tool for monitoring, analyzing sent and received data packets and analysis of the network protocol. By Wireshark Tool, I can make sure that the data sent from my device, which has the IP address of this, colored with color blue, and it's sent to destination with IP address of the ThinkSpeak cloud. The importance of my system lies in its role in decreasing the robbery attempts, controlling room's temperature, and decreasing the number of deaths caused by fires and gas leakage, which is the third goal of the Sustainable Development Goal of UNDP. My future work, I'm planning to add a webcam to the system and train it for face recognition. This will increase the security affairs, to connect the system with a mobile application and control the appliance from this application. This will enhance the overall controlling and monitoring of the system. And instead of using electricity to power the system, I will power the system using solar energy. This will decrease the cost and hence increase the number of homes that will use my system. Thank you.
Yeah, can you hear me?
Yes, I can.
Yeah, good presentation. The first point I would like to know that which part of security you have achieved here, because in security there are many features, right? There is authentication, there is access control, there is trust management. So there are many things in security. So What exactly you have targeted here?
Okay, I'm not sure if I understand your question accurately, but the security setting that I use is to make sure that my data will be only sent to the channel I've created in my website. So nobody else will be able to monitor the data that is sent by the sensors. Otherwise, if anybody can monitor the data, they will be able to, let's say,
Data security. Data security.
yes.
Okay. So have you verified your solution against some attack?
What? I didn't hear that. I'm sorry.
Yeah. Have you validated your solution against some attacks?
I'm not sure. Can you write it, your question? I'm not sure if I can understand it.
Yeah, I will write it in the chat box. Okay.
Okay.
Please read.
No, I haven't.
No.
Due to time constraint, I'm sorry, but I've launched the Wireshark tool and make sure that the Wireshark tool works well. I can show you if you want.
Okay. And what is the implementation you have implemented in which programming language?
And Arduino IDE. I can use the Python, but I feel that the Arduino IDE is easier.
Okay. And what is the cost of total implementation, hardware and software?
Well, my supervisor gave me some electronic components, and I was able to buy some other components, but it wasn't that expensive. I don't know your currency.
Okay, fine, good. All the best. Thank you.
Thank you so much.
Thank you for your great presentation.
You are welcome.
Okay, so now we'll move further to our next paper. And I would like to invite Matthews to present his paper on the title, Using Machine Learning and NLP for the Product Matching Problem. Dear presenter, you may please start your presentation.
Hi, can you hear me?
Yes, we can hear you. Please go ahead.
Just one moment. Are you seeing the presentation?
Yes, it's visible.
Okay. Hi, my name is Matheus Alcântara de Santana, and I'm going to present to you our paper named Using Machine Learning and NLP for the Product Matching Problem. E-commerce has grown every year with more than 2 billion digital buyers, and this number is only increasing. With the increase in the number of consumers, which represents the demand, the number of retailers selling the same products increases too. On the other hand, there is some interest in some way or mechanism to somehow group these offers. For example, to an interest buyer to compare prices between different sellers, or to the retailer point of view, analyze competitors' prices. These are only some scenarios where a resource like this would be beneficial. But this task of pairing identical products that are from different online marketplaces is not trivial, as different suppliers describe the same product in diverse ways, using distinct characteristics, even misspelling them. There are some unique identifiers for products like European article number and global trade item number, but these identifiers can be incorrect or missing, as the information is not relevant to sales. So what is product matching? Product matching can be defined like a technique of giving two or more descriptions, classify them as being or not being referred to the same entity in the real world, using machine learning and natural language processing. In this paper, we're focused to implement a machine learning model capable of group the same products from government purchases, which will be used by the Court of Accounts of Acre, a public spending inspection body in the Brazil, to be used in analysis that allow the identification of the average prices of these products, and has result in identify abusive costs in the buying process, ensuring that the correct government budget execution is applied. So our work was divided by based on the cross-industry standard process for data mining methodology, which has 6 steps. First one was business understanding. We seek to assimilate the problem better and learning more about the business rules. The data understanding that aims to understand and explore features available in the data and identify possible problems with them. Data preparation, whose objective is to select the attributes we use, removing unwanted features. Modeling, that aims to test the classification models, identifying the best parameters to be used in the database. Evaluation, which seeks to analyze the metrics of previously trained and tested models. And finally, deployment, which the best model is chosen from metrics obtained previously and deployed in the real scenario. So, in the business understanding phase, our focus was understand how to use the data to achieve our initial goal. In this research, a database of invoice issued in the state of Acre from Brazil, from the Court of Accounts of Acre, was used. In the data understanding phase, analysis of available information in the database was made. Each record of the database contained information of the products, like quantity, price, and so on. After the given analysis, is selected the following attributes. First, the description is basically the product title. The EAN, as I said earlier, is basically the barcode, and we use to unique product identifier. The NCM, which stands for Mercosul Classification Nomenclature, is a text classification, but we use them to group similar products into classes. Still in this phase, the quality of the information was checked, and some errors in the attributes were detected, like invalid EAN and NCM, repeated product descriptions, useless special characters. In addition, we noticed that some measurement units, such as kilograms, meters, and liters, among others, were abbreviated in different ways, but meaning the same unit, which could harm the model performance. So, in the data preparation, we addressed this error noticed in the previous step. We removed the invalid EAN, basically using the defined format for the EAN in removing the invalid ones. Removing the repeated descriptions. We observed that we had some descriptions that were repeated, so we removed them. Removing the invalid NCMs. A valid table can be consulted in one of the government bodies' website. So we removed every NCM that doesn't belong to that table. We did a measure standardization using regular expressions. Basically, we replaced the most recurrent units of measurement with a standard representation. As we see in the example, the unit meter was represented like a MT, or MTS, and we converted using regular expression to meter. and some useless special characters that doesn't mean anything to the data. So next was necessary to find a description that represent a given AAN, which was representing a real world product. The model can compare and decide if a specific pair of descriptions from the same was the same product or not. So it was defined as a canonical description. We name it like it, and which was the most frequent description of a given AAN. At this point, after the inclusion of the canonical description in every record, all the data was correct because every pair of description in our database was talking about the same entity, the same product. So all the data was labeled as match equals 1. But some wrong data was needed to train the model correctly. So we randomly generated this data and labeling them as match equals 0, making sure that first we are creating a new record with a description and a canonical description that do not correspond to the same product. And these two products had the same NCM to maintain some similarity between them. We observed that this method of annotation had generated some wrong data. So trying to eliminate some more wrong annotated data, it was used the following heuristic. Giving the description and the canonical description of a given product, only the record in which both the descriptions have at least one of the first two words in common will be valid. So it was an important method to improve the model performance, as we will see later. In this image, we can see an example of above in the table, a valid pair of description, and below invalid one using the heuristic. These records were taken from our database, just translated to English. So in the modeling phase, we had two types of classification model. The traditional ones composed by random forest, XG boost, naive Bayes, and SVM, and deep learning ones composed by only BERT. BERT, we used a variation of BERT, is called BERT Timbal, and BERT train with which is a BERT train with a Portuguese corpus. It was used along with BILSTM. We use scaffold cross-validation in the train and the test using k equals to 5, and training test division was 72% to training and 30% for test. The BERT model, like I've said earlier, was used along with BILSTM and using techniques like global max and average pooling and dropout to reduce overfitting and improve overall performance. We used 4 epochs to train our BERT model. In the evaluation phase, in order to apply some kind of ablation test, the model were trained with and without the previously defined heuristic to the data, in order to verify the sensitivity of the models to incorrect data. The test allows us to observe the use of the proposed heuristic, and if the model improved with a cleaner data set. As we can see in the table, the model with the barometrics was the BERT plus BILSTM using the data with heuristics applied. In this graph, we can see a receiving operating characteristic curve, and we can observe the barrier performance of the BERT represented by the purple line right here. And to conclude, the model to be applied in the real scenario due to the barrier metrics is the BERT plus PILSTM using data with heuristics to train the model. It will be used to remove invalid products from the invoice database. As future work, we intend to improve the data pre-processing step, aiming to minimize inconsistent items. For example, we can use attributes such prices that can improve the extraction process for these products. Also, hyperparameter optimization methods can be used further to improving the model performance. The authors would like to thank to the Court of Accounts of Acre for funding this research. Thank you.
Hello.
Hello.
Can you hear me?
Yes.
Okay. So I have a very fundamental question first. Can you explain some real application where you require product matching problem?
Sorry.
Can you give me an example where you need to match two products on the from dataset? Is that question clear?
I think so.
Okay, I'm texting in the chat box.
Okay.
Okay. You can please read in the chat box. A very fundamental question. Yeah.
Yes. The deployment phase we proposed to use it to identify to group similar products to the Court of Accounts of Acre is a specific inspection body of Brazil, to how can I say that? Sorry. To allow identification of when we group these products, we allow to get average of these prices and get some outliers, like let's say product like rice. We can see governments with an average grouping these products. We can see our average, and we can identify some abusive by the government.
Okay. Okay. Have you used any performance hypertuning parameter?
No.
Okay. Then you have shown some different classifiers. So which one you found best in your knowledge?
The BERT used along with BILSTM.
BILSTM. Okay. And do you think that there can be better output with deep learning as well?
Sorry?
There will be better optimization using neural networks. Do you think so?
Yes. In the results, we saw that it was better than the traditional ones.
Okay. Fine. That's good. Good problem. Good paper. Good research. All the best.
Thank you.
Madam, you are mute. Anisha, ma'am, you are mute.
Oh, sorry. Thank you for your great presentation. We'll move further to our next paper. And I would like to invite Victor Hugo to present his paper on the title, Impact of Digital Marketing on Huda Marquee Company. Dear presenter, you may please start your presentation.
Good morning, ladies and gentlemen. My name is Victor Hugo Guadalupe Mori. I am professor of System Engineering faculty at the University San Juan Bautista from Lima, Peru. I will start with my exposition. 2022 Words for Conference, Impact of digital marketing on Budamaki company. Introduction. As a philosophical principle or business, I can be defined as a process of management for the identification, anticipation, and satisfaction or customer needs in a profiled way for the organization or company. Among the models, artisanal production, sales, marketing, and social marketing. The last on the theme is considered an orientation based on strategic planning and a greater long-term vision. The main function or the market activity are research, innovation, and creation, or new products and service. Determination of price, indetermination or distribution of tourist service, communication, internal marketing, and planning. Methodology, definition of terms. Web systems are hosted on and served on the internet or the intranet. Python programming language. It is an interpret programming language, multi-paradigm and multi-platform, used mainly in big data, all data science, testing frameworks, and web development. Methodology, system architecture. It is to assume and care on the responsibilities of a process. This can be business or personal. Which include concerns for the disposition of the resource and structures necessary for it to have a role in trade. The coordination of their activities are their peers, efficiency, safety, reliability, maintainability. Methodology, prototype development. In the final phase, the navigable prototype or the entered website will be made here where the entered navigation struct will be displayed as well as the completing design. Result. About the use that the world population makes of technology. Digital marketing has become an increasingly attractive alternative to commercialization based on the use of technical resource and digital media for the development of strategies based on the establishment of direct communication with the client in order to achieve the sales or products or service that positions on brands or loyalty the team. Map of Peru cities with internet access. No? Lima, Callao, Tacna, Arequipa, Ica, Lambayeque, Moquegua, La Libertad, Tumbes, Junín, Loreto, Ancash, Apurímac, Piura, Amazonas, Ucayali, Madre de Dios, San Martín, Cusco, Huánuco, Cajamarca, Puno, Pasco, Ayacucho, Huancavelica. Results. Benefits of using digital marketing in companies. The internet represents an element of great advantage for Colombia companies because it offers a window to the world that facilitates better interactions with customers as well as know characteristics, news, and trends on the market in which it operates and by the SAMs make themselves? No. With the investment of fewer resources of time and capital. Results: commercial process. Hand in hand with the above, the commercial process development with the support of the internet achieve a greater sales of products and a better interaction with customers and suppliers through the use of specialist tools, the customers relationships management with optimized commercial attention and offer great accessibility and an ability for information flows. Conclusion: the implement and development of a web application for the improvement on the digital marketing in the Budamaki company will allow in the become a more recognized company, which will generate great income for the company. That of client server system of web type will allow adapting the use in the new versions on the developed system. Of the other hand, the system offers portability towards the various brands on operating system. Reference: Uribe and Sabogal and Gerald, 2021 Digital Marketing in Micro and Small Advanced Companies in Colombia. Thank you for much for all yours. Universidad Privada San Juan Bautista, Lima, Peru, World Conference on Smart Trends and System Security and Sustainability. Thanks.
Yeah. Hello, Professor. Can you hear me? Hello, Professor. Can you hear me?
Yes, sorry.
Yeah. Can you hear me? Can you hear me?
Please.
Hello. Yeah. What is Budamaki company? Yeah. What is Budamaki company?
It's a company, Colombian Budamaki.
Okay. And what
company
are
Budamaki.
Okay. That's very good. What are the different web services you have used? Which web services you have implemented?
It's a system tribunal.
Okay, fine. Thank you.
That's it. Thank you. Welcome.
Thank you for your great presentation.
Thank you so much.
Okay, so we are moving on to our next paper. And the paper presenter is Victor Hugo again to present his paper titled Industry 4.0 Implementation of Technologies in Medical Manufacturing Companies. Dear presenter, you can start your presentation.
Correct. Thank you very much. A moment, please. I am going to project yes.
Yeah, please
Okay.
start.
Perfect. Thank you.
Excuse me, Víctor. ¿Puedes ponerlo, Víctor? ¿Te parece?
Okay.
Yeah, yes. Yo. Yeah, okay.
Yes.
I am speak, yeah. tu video,
¿Sí se
Víctor.
ve? ¿Se ve mi pantalla?
Afternoon, everybody. My name is Enrique Gutierrez from Lima, Peru. Victor, I'm gonna continue with the presentation related with implementation of technology in medical manufacturing companies. Please.
Okay, thank you. Good morning, ladies and gentlemen. My name is Victor Hugo Guadalupe Mori. I am professor of system engineers faculty at the University San Juan Bautista from Lima, Peru. I will start with my exposition. 2022 Words for Conference, Industry 4.0 Implementation of Technologies in Medical Manufacturing Companies.
Next presentation, please. Go to introduction. Introduction, please. Well,
Introduction.
yep. The concept of Industry 4.0 appeared in Germany in early 2010, coined by the multidisciplinary group of specialists convened by the German government to design a program to improve the productivity in the manufacturing industry. Well, the term was first introduced at the Hanover Mess in 2011 and quickly gained a highly popularity. And the industrial sector is considered an engine of innovation, and everyone knows about that around the world. Growth and social stability too. However, competition is becoming increasingly intense. The fourth industrial revolution is the digitalization phase of the manufacturing sector, driven by increased data, computing power, and connectivity in that, well, worldwide. Next. Next presentation, please.
Yes.
Well, Industry 4.0. Well, combining advanced manufacturing operational technology with intelligent technology, we promise a new revolution in integrating organizations, people, and preparing. That's the future. In manufacturing, it is a work organization system that focuses on improving the production system. Well, that is the definition of the term that we are going to use around this presentation, please. Next. Well, a methodology or the framework. Well, the research objective. The healthcare industry is currently dominant in many European countries, but it is also dominant around the world. In our research, we decide to evaluate the fitness and progress of companies in the implementation of technology and automation elements of the fourth industrial revolution. Studies with a similar approach at this level have not yet been documented, so we believe that this study will be useful for what we apply into healthcare industry. The goal of our work is to identify the level of technology usage within industry, focusing on automation, super, and samples from Slovak and Czech companies in the healthcare sector in Europe, Middle East Europe, I guess. The survey also used questions about implementing automation, providing IT services, network failures, or industry super technology too. Next, please. Well, continue with the methodology, research sample and data collection. What's that? To collect data, we conduct a survey using a secret quiz that allows company to freely express themselves. That's very important. And the quiz is designed to help detect a more comprehensive pictures of the Peruvian medical device regional manufacturing industry of Lima. Well, Lima, where we are we have a low technology in cases like that. Not also technology, also maybe methodology, or good universities or universities who teach something more. University who provide more professionals with highly knowledgement related with healthcare and in the industry of Lima. While preserving to know how aspects of these companies for data collection, we choose to use an electronic questionnaire. The questionnaire was sent to about 5 select companies operating in Lima. We have chosen companies like Jaime Rojas, sorry. The survey was addressed to operational managers or technical director. Comprehensive analysis on the market and external and internal conditions, supplier network and technical staff, and independent research are basic requirements for success in conditions. Next, please. Well, we have a table here, and this is a survey. We have variables, category, and quantity. We have the size, the year, and the life cycle too. In the category for sampling size, we have a micro and little, medium, big, and also the total. That's only the quantity. In the variable year, we have lower than 5 years, since 5 and 15 to 15, sorry, upper than 5 years. We have also life of cycle, establishment, growth phase, stabilization, critical phase, and the quantity numbers too. Next, please. Well, as the results and discussion, we use the next chart, number 1, not automated production introduced. 2, significant utilization level. 3, medium utilization. 4, higher automation level, benefits such as improved production efficiency. Cost reduction, digitalization of paper documents, elimination of errors and malfunctions. Improves product, simplify production process, tracking tools, downtime forecast, every view of current production status. Finally, I finally confirmed that to make work more stable and defensive. Next, please. Before 1, please. Well, this is the degree of implementation of automation elements. For example, we have no implemented automated production, 13%, by vital degree of utilization, 33%, and 42% is a medium degree of utilization, and 12% advanced degree of automation utilization, very, very low. Well, we have advantages in realizing automatic productions. You have simplification of production process. You have optimization of product quality, cost saving too, and growth of the production efficient. How efficient would be this place in the futures, and things like that. Next, please. Well, this is our reference. We collect all information, and my partners also collect the information that I tell you from all of these the things, and that's all. Thank you very much, sir.
Yes. Can you hear me?
Yes, sir.
Yeah. Can you explain what are the challenges you face for Industry 4.0?
Can you repeat that question, please? I can understand very well.
What challenges you have faced while implementing Industry 4.0?
So sorry, I can understand very well.
Challenges.
What about the challenge of this our research?
Right.
Okay. Well, one of the challenges is to enhance this community, to enhance, for example, medical establishments, and the most important is to enhance and become to be a good professionals. and we need to enhance our to get ahead with these topics, and to have better establishment, better professionals, and everything related with healthcare. Not so much about society why 5
Okay.
or 0. Thank you
Fine,
much.
fine. Okay, thank you, thank you. Good. Anisha ma'am, we are done.
Yes, sir. Thank you for your great presentation.
Thank you.
So I think all are done. All presentations are over, right?
Yes, sir. Now all the papers have ended. I sincerely thank all the presenters for their excellent presentation and contribution in the session, and all the participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 5th version of the conference. We will be happy to have you in the 7th version in 2023. All the presenters would be getting their digital certificates through email within 2 to 3 working days. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4. I also like to thank our session chair for chairing this session. Here is a token of appreciation on behalf of the team of WS4 and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you so much. Thank you so much.
Thank
Okay.
you.
So as we have come to an end of the session, I would request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much.
Thank
Stay
you so
safe
much.
and take care.
Thank you. Take care. Bye bye.
Goodbye.
Bye.